Alright, on the previous video we solved quadratic formulas. So we solved quadratic equations using the quadratic formula. And so it's anytime you get a quadratic equation equal to 0, you can solve it using the x equals negative b plus or minus square root of all that stuff. And so here were two of the examples we had. And then there's a third one that we did not look at that is at the bottom here. So throughout the years, your teacher, well, let's get to that in just a minute here. I guess I was going to say your teacher said you can't do the square root of a negative number. But let's see what happens when we do the quadratic formula here. So we get x equals negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 2, times c, which is 10, all over 2a, which is 2 times 2. So we get x equals negative 4 plus or minus the square root of 16 minus 80 all over 4, or x equals negative 4 plus or minus the square root of negative 64 over 4. Now, throughout the years, your teacher said, well, you can't do the square root of a negative number, because there's no number that multiplied by itself will give you a negative number, because negative times negative is always positive. So it just can't happen. Well, today your world's going upside down. The square root of a negative number can happen. In fact, the square root of negative 1, many years ago, two guys named Euler and Cardan, I don't know who came up with it first, but they decided, let's make the square root of negative 1 I. So it's an imaginary number. And now there's just a whole new set of numbers that are called imaginary numbers. This allows us to do the square root of negative numbers. And it seems kind of crazy. Why are there imaginary numbers? But they are useful in some very niche circumstances, mostly in physics, but they do come up every once in a while. But today you're going to see why I've been saying you need 2 answers for every problem. Because before your teacher would say, well, it's just not possible. There's 0 answers for this. Well, there are 2 answers. The square root of negative 1 is I. Then let's look at this a little differently. We get negative 4 plus or minus the square root of negative 1 times the square root of 64 all over 4. So we get x equals negative 4 plus or minus, well, the square root of 1, or square root of negative 1 is I, and the square root of 64 is 8. So this is going to be 8I over 4. And then we can simplify this. Negative 4, 4, and 8 are all divisible by 4. So this ends up being negative 2 plus or minus, oh, I'm sorry, that's wrong. Negative 1, we divide all these by 4. We get negative 1 plus or minus 2I over 1, or we can just leave it like this. So what? So what does this mean? Well, this is a complex number, negative 1 plus or minus 2I. And this tells me something about the graph. And one of the things we haven't talked about much in these videos is what happens on the graph of this. So what happens on the graph of this example here? What happens on the graph of this example here? And this one? Well, this one had 2 answers, 6 or 3/2. Well, guess where it crosses the x-axis? 6 and 3/2. This one had 1 answer. It is negative 3. Guess where it crosses the x-axis? At negative 3. This one has 0 real answers. It has 2 imaginary or complex answers. Guess where it crosses the x-axis? It doesn't. And let's look at those graphs here. So for the first one, we said it crosses at 3/2 or 1.5 and 6. This is the graph of that first example. The answers for the quadratic formula tell you where it crosses the x-axis. And that's when it equals 0. That's when this equation equals 0, because this is the y equals 0 line. Okay? This one, the answer was negative 3, and that's where the parabola crosses, is at negative 3. It just barely touches at negative 3. Okay? And then the other one, how can it have no answer? Well, it's a parabola, but it doesn't cross the x-axis because the minimum is above the x-axis. So the imaginary answers are 1, or what was it, negative 1. Let's go back here. It was negative 1 plus 2i and negative 1 minus 2i. And once you get familiar with working with imaginary numbers or complex numbers, that will mean something to you. But for now, what it tells me is it tells me that it does not cross the x-axis anywhere. So the main idea here is what we keep solving for is where does it cross the x-axis. So back to this from the other day. If this is positive, you get 2 real solutions. If it's 0, you get 1 real solution, so it crosses the x-axis once. If it's negative, it doesn't cross the x-axis at all. So we're talking about the discriminant here. This is the stuff under the square root. If you end up doing the square root of a positive number, you're going to get 2 answers. If you do the square root of 0, you get 1 answer. If you do the square root of a negative number, you get complex or imaginary solutions. So that's using the quadratic formula where you end up with imaginary numbers. And I really want to emphasize that's where it crosses the x-axis are the answers to each of these equations.